Hello everyone, this is the third year Nat5 course again, third lesson in the angles and circles unit. Um, so we look at the learning outcomes again. So we're on the third one tonight, this one here. So we're going for identifying right angled triangles in a circle. Um, and instead of using the last lesson was about using Pythagoras' theorem to solve problems, this lesson we're just going to be looking at solving some angle problems. So let's have a wee look. So, got a wee circle here. Let me draw on, I'm going to start with a diameter line. Right, so diameter goes through the centre of the circle, like so. Right. From at each end of the diameter, I'm going to go for A and C. And then what we'll do is we'll draw in two chord lines. Now, the first chord line that you draw can go from one end of the diameter anywhere around the circle, right? So anywhere around that arc. You can even go this side of the diameter line, if you wanted, but anywhere around the arc. So let's go for about here. In fact, I'm not very happy with where that line has ended up. Let's draw it again. There we are, perfect. Right. Let's draw a chord line from A out to meet C. There we go. Right. So what I've done is I've formed a triangle inside my circle, right? Made up of AC being the diameter, AB and BC being two chords of the circle. Now, if I put my protractor tool on, right, we'll see something pretty interesting. So what I'm going to do is I'm going to measure the size of the angle at B. So let's get that as accurate as we can. Spin that around, and yep, pretty happy with that. So what we've got is, you can see from here that the protractor measures the angle, I'll write it up here, angle ABC is 90 degrees. Now, that scenario happens anywhere around that circle. So long as we've got a diameter and two chord lines that make a triangle, that triangle is always right angled. Always right angled. And now, I would urge you, usually when we're doing this in class, I would usually get each one of you to draw your own circle, draw your own triangle, so we've maybe got 30 different sized circles and triangles, and you would all get the same result. So I would urge you, if you've got a protractor at home, I would urge you to try that little task. Draw a circle, draw the diameter, so long as you know where the centre is, so that it's a true diameter. Draw a circle, draw the diameter, draw in two chords, measure the angle at B, and you should find that it's 90 degrees for yourself. So, here a wee note for you to copy down. So we're saying when two chords in the diameter form a triangle inside a circle, that triangle is always right angled. Now, here's a sort of fairly typical standard example, okay? In the circle below, find the missing angles, right? Well, we've got two missing angles inside our triangle. We've got this one here, this one here. So we need to find these two. Now, you will always have to identify the right angled triangle for yourself, right? So what you should be doing is taking a little look and saying to yourself, right, I've got a right angle up here. So that bit you should be doing yourself. And then because we now know two of the angles in the triangle, then nice and easy, the other angle is 180, take away 90, take away 35. Okay, and that comes to 55. So, putting in the right angle yourself. Now, this one's a little bit trickier. Again, you need to spot. You've got a diameter line, two chords, so straight away, that's a right angle. Right? There's no, you don't even need to think really about it. Just identify your lines that you're seeing in your circle. Diameter, two chords, that triangle's right angled. It just has to become automatic. The issue is, how do we find the other two angles? Well, you were given a clue here of 158 degrees. So we're going to start by working out this angle here. Well, that angle lies on a straight line with 158 degrees. So we just have to do 180, take away 158, 22 degrees. And the third angle, now we're inside the triangle, we do 180, take away 90, take away 22 degrees. So 180 take away 90 is 90, 90 take away 22 is 68 degrees. Done. So, pretty short lesson, that one, right? The key point there is that you've got when you've got a triangle inside a circle made up by a diameter and two chords, then that triangle is always right angled at the angle that lies opposite the diameter line. Okay, so short exercise for you to do. I want you to go and have a look at exercise 10.7 from your textbook. Keep sending me your solutions. Keep sending me pictures of your jotter work. I'm really enjoying seeing that. Keep going and keep working hard.